Hello students, in this section we are going to discuss about the conductivity in solids. Okay, about the metals we are going to discuss in this particular section. So let's start here, conductivity in solids. Among solids, I just told you that metals are the good conductors of electricity. So it's given here whenever we are going to talk about the conductivity, we have to understand that we are going to take a conducting substances just like they are made from a metal. So we have like number of examples. You can take like copper, aluminium, silver. These all are the metals and they all are able to carry the electric current. Okay, in a metal atom, a few electrons are loosely bound to the atom. So whenever we look at the structure of metal, we have to understand that the current carriers are in the form of free electrons, and that is the reason we are telling you it's a good conductor, because these free electrons are able to carry the electric current. Next point which we have, solid metal atoms are not free to move. Whenever we look at the solid metallic atom, solid metal atoms are not free to move, but electrons are loosely bound to the atoms. When we look at the structure of atom, as you all know that in atom there are number of particles, right? These three particles like proton, neutron and electrons. Proton and neutron, they are reside inside the nucleus, and that is the reason they are not able to move. But electrons, they are moved in the outer shells, so they are able to move. They are able to move freely when we are talking about the solid metal. Can move easily in the solid piece of metal. Okay, next point says that these electrons are called free electrons. Okay, these electrons which are able to carry the electric current are considered as a free electrons or conduction electrons. Why we are telling you it's a conduction electrons? Because they are able to carry the current. Okay, these are actually conductive in nature. Next, among non-metallic solids, when we talk about the metals, we told you that copper, aluminium, silvers, these are the best examples. But when we are going to talk about the non-metallic, always remember graphite, it's a good conductor of electricity. Next, when we will talk about the insulators, we know that we have number of examples: wooden pieces, plastic, rubber, air, glass, bakelite. These all are the insulators. And we know that insulators are those substances from which electric current cannot pass through. When the electric current cannot pass through, because here electrons are bound tightly, and that is the reason they are not able to move easily. Okay, electrons are bound tightly, cannot move easily, thus they are actually the poor conductor of electricity, and that is the reason we consider them inside insulators. Next, we have an important note here: charged particles which flow in a particular direction. Okay, charged particles, that means in solids we are taking free electrons that is going to move, that is going to flow in a particular direction to produce an electric current, are called current carriers. In solid conductors, current carriers are free electrons, because these free electrons are able to carry electric current. And here we are talking about the metals. Here we are talking about the solids. Among metals, silver, it's the best conductor of electricity. Like we have the number of things. Okay, it is also followed by copper, gold and aluminium. Okay everyone. Next, here we are going to show you an activity. To perform this activity, what we have to take, we are going to take a cell. Okay, this is a bulb. Here we have a switch. This is a whole setup. Now when we look at here this is a insulating ball, and here we have a conducting ball. We are going to show you that when we will going to place this conducting ball, and when the circuit is going to be completed, like it's in the closed position, and when you connect conducting substance here, the bulb glows. But when you remove the conducting ball and you replace it by placing the insulating one, you will find out that bulb doesn't glow. Okay, so let's see here what is going to happen. We will connect it, right? Bulb glows. Okay, so that means it's a conductor substance, right? Exactly. Now we will replace it. We will actually going to place here insulating. Look at here, bulb doesn't glow. Okay, it is actually a kind of experiment. By doing this experiment, we all are able to understand, and you can also able to find out which one is conductor and which one is insulator. It is a kind of electric tester experiment. First point, bulb glows when metallic part is connected in the circuit. Metallic part, that means when we are connecting conducting substances. Okay, Bulb does not glow when plastic part is connected in the circuit. Plastic, because it's an insulator. So this is how we are able to understand, and this is how you also, when you can also perform this activity at your home. It's a very simple thing, okay? And by doing this, you can understand the points, what is the difference between the conductors and the insulators. Next, let's see what we have. Like, we just perform an activity, so obviously we have the final conclusion. Metals like copper, aluminium, iron, etc. are good conductors of electricity, while materials like rubber, wood, glass, plastic, porcelain are poor conductors of electricity. The above setup can be used to test whether a material is conducting or insulating. Thus, that is the reason this setup is called electric tester. Okay, by just performing this activity, you can find out which one is conducting and which one is insulating. Let's see, next topic we have light emitting diode, LED. Okay, so we all have seen LEDs, right? The first point, light emitting diode, LED, can be used in electric tester on the place of electric bulb, right? Why we are going to replace this electric bulb? Because we have to light up the electric bulb and then we are actually going to provide higher voltage. But if you are taking LED, it can also be glow if you are like providing a small amount of current, okay? So LED glows even when a weak electric current flows through it. Like if you are connecting LED in the place of bulb and you are just providing a small amount of current, like a weak current, LED start glowing, and you can find out that which one is conductor and which one is insulator. There are two wires which is called LEDs attached to an LED. One is longer and the another one is a shorter one. Now, one LED is slightly longer than the other, okay? So the longer one is actually going to connect it with the positive terminal. Always remember this point. The longer LED is always connected to the positive terminal of the cell or a battery. So it's now very but obvious, right? The shorter one is going to connect it with the negative terminal of the cell or a battery. This is a longer one and here we have the shorter one. So next we have examples. Okay, we have the first examples, but I just want to tell you something. In this section, like we discussed about the conductivity in metals, and we know that metals are the good conductors because they have free electrons, and those free electrons are considered as a current carriers. And just like if you are talking about the plastic, wooden pieces, air, these all are the insulators because they doesn't have free electrons, right? The electrons are tightly bounded and that is the reason they are not able to move freely. So let's see the first question which we have. You also know the full form of LED, it's light emitting diode. Okay, a weak current can be detected by replacing electric bulb in an electric tester. We just discussed about the experiment of electric tester, and even I told you, if you are connecting an LED by just replacing an electric bulb, and if you are like providing a small amount of current or a weak amount of current, LED start glowing, and this experiment is also a part of electric tester. So the correct answer of our question is option A, LED. It's the correct one. Alright, let's move on the next question. Solid NaCl, that means solid sodium chloride, is a bad conductor of electricity because sodium chloride, here we are talking about the sodium chloride which is like in the form of solid form, and in solid NaCl ions cannot move freely. So let's click on the B options. Okay, B, it's the correct answer of our question. Now I hope it's clear to you. We just discussed about our section. Please go through the content and solve the relevant question which is based on this section. Thank you so much everyone.